Okay, so today we're talking about projectiles, woohoo, and projectile motion. So fun. So what we gotta first talk about is what's always getting you down, gravity. So what's gravity? Gravity is a constant acceleration. Alright, we're going to talk more about it later, but for now, it's an acceleration. It is the magic number. It is 9.8 meters per second squared, and it is going down. Do you hear it? It's yelling timber. So, since it's always going down, by down we mean to the center of the Earth. So if you're in some place weird like Australia, it's still going to be going down, even though your down is a different down than normal people's down. Got it. All right. So the main idea here is it's an acceleration, okay? All right. So that acceleration doesn't care about how big your object is, but it's the same amount for everything. And we're going to use this in conjunction with all that fun motion stuff that we did before. All right, let's do one. So we've got a truck. It's a nice truck. It's going to drive off a cliff. It's driving at 22 meters per second, and the cliff is 150 meters high. I want to know what this distance is. How far will the truck go before it goes boom on the ground? Okay. Now, whenever you're doing some two-dimensional motion projectile thing, you're usually going to shoot for time. You're going to need time. All right? Not always, but usually you want time. Okay? We need to know how long the truck was in the air before it hits the ground. Now, to do this, to find time, you're usually going to find out, you talk about your y direction. All right? So in this direction right here. Now remember what we talked about the other day when we talked about XY independence, okay? So we're going to talk about motion in the y direction. Now we're going to need one of those fancy formulas here. Do you know which one? We're going to need the second one. So we're going to have d is equal to d0 plus v0t plus 1/2 at squared. Okay, this is the formula that we are gonna need. Now, there's some things that we know. How much distance do you cover? You cover 150. Starting from nothing, because we can call this 0, right? Plus v0, what's your starting speed? Your starting speed is not 22. Your starting speed is 0. Because this guy, what we're doing right now, is only the y direction. Since you're driving level off of a cliff, how fast are you going up and down? You're going up and down 0 meters per second. So you have no starting velocity. So times time, but whatever. Plus 1/2 times acceleration. Your acceleration is 9.8 whenever you're doing gravity, t squared. Okay, so that's what we got. Solve time. So time is going to be about 5.5 seconds. Okay, so far so good. Now, since we have time, we're going to talk about your x direction. Okay, so when we're talking about our x direction, we don't have an acceleration. We don't have an acceleration because gravity goes straight down in the y direction. There's no x part of acceleration from gravity. So your distance is just going to be velocity times time. Now you could use like this formula and then just cross that part out. It's the same thing, but whatever. Velocity times time. Which velocity are we going to use? We're going to use the 22 because this is the x velocity. Times time. Time is the same as what we had a second ago because you're going to be in the air for 5.5 seconds. Each one of those seconds, you're going to move forward by 22 meters and a half. So that'll give you just about 122 meters altogether. Okay? So the important thing, the misconceptions of the world, right, is you're not going to be moving any faster in the x direction as you're falling down. You're just going to move faster downwards. Your horizontal speed is going to stay the same. Okay, awesome. Let's look at another one. So there's two things here. So the first one is what's your speed, and then what's your speed when you hit the water. So what you're doing is you're running off of a cliff, and you have to make it over the sandbar and land in the water. This way you don't break all your leg bones. Okay, so we want to know what's your velocity, how fast are you going, and then how fast will you be when you hit the water. Okay, so let's figure out your speed first. Well, we have to make a decision of what formula we're going to use and all that stuff. But first we should look for the time. We want to know time. So see if you can figure out which formula gives you the time. Pause the video. Did you do it? It's the same formula as last time. D is equal to D0 plus V0 t plus 1/2 AT squared. How far are you going to go? You're going to go 11 downwards from nothing. How fast are you going? You are going no fast because it's the y direction. Plus 1/2 times 9.8 times t squared, and t squared, t is going to equal about 1.5 seconds. Okay, so now that we have that, we can figure out our running speed. We've got 1.5 seconds and we have to cover 10 meters. So that means that we'll have to cover, our velocity is going to equal distance divided by time, which is going to be 10 meters divided by 1.5 seconds, because you have to cover that much distance in that much time. So divide those guys and you're going to have about 6.7 meters per second. If you run any slower, you're not going to have a happy landing. Okay, so let's do the second part. How fast are you going to be going when you hit the water? Alright, so we need to find your velocity as you're landing here. So there's a couple ways to do it. What I'm going to do is I'm going to find your vertical velocity, because I know my horizontal velocity already. So we're going to have a vertical velocity and we're going to have a horizontal velocity. Horizontal velocity is just 6.7. See if you can figure out your vertical velocity. There's more than one way to do it. Pause the video, give it a shot. Okay, let's see. Now, there's more than one way to do it. I'm going to use equation number 3. V squared is equal to V0 squared plus 2AD. Alright, because that's a 0 plus 2 times 9.8 times 11. So that means my V is going to equal 14.7. Now that's the same thing as 1.5 times 9.8. I did it this way because I'm using stuff that's already given. I don't know. It doesn't matter. I wanted to use this formula, okay? I'm sorry. But this is not your entry speed. This is just half of it. Well, sort of. So 14.7. So we have to figure out this vector here, which is about 16 meters per second. So that's how fast you'll be going. Let's do another one. Alright, so here's one. You're riding your bicycle and you're going to go off the jump, and then you are going to knock the apple off of your assistant's head. Now your assistant is 5.5 meters away from the edge of the jump, and the edge of the jump is level with the floor that your assistant is standing on. And here's 20 degrees is the angle of the jump, and your 13 meters per second will be maintained until you get airborne, because you are going to be pedaling the whole time. Alright, so the question is, how tall can your assistant be for this to work without having a bunch of lawsuits? Alright, pause the video, see if you can figure it out. Okay, so the first thing we should have done is we need to break apart your 13 meters per second into its two components. Okay, so 4.45 and 12.22. Those are both meters per second, right? So what we need to do now is figure out the time it takes to go from here to here, right? Because we need time at this critical moment. Now you're traveling at 12.22 horizontally, so that means that our distance divided by velocity is time, so distance is 5.5, 12.22. That means the time it will take us is about 0.45 seconds to reach our assistant. And now we just got to figure out our height at that point. So we're going to be using equation number 2, d0 plus v0t plus 1/2 at squared. Okay, so I want to know what's our height. Our starting height is 0 because we're starting at the ground level, plus v0, our starting velocity, is 4.45 times 0.45. Now, plus 1/2. What's our acceleration? Our acceleration is 9.8, but there's a problem here. Our velocity initially is going up, our acceleration is going down. Both of these two things can't be positive because they have a direction, so this guy is going to be negative. Now, you could have done it the other way, -2, but that would be grosser. So, 0.45 squared. Right? Because our velocity points the opposite way as the acceleration, one has to be negative. They can't, because they're both vectors. All right, so then you just type this into your calculator, and you're going to get d is just over 1 meter. So you're going to have a very short assistant, hopefully. Okay, we got one more for you here, because I know these are a little tricky. So this time, we're going to drive off a ramp over the ledge. We're going to just see how far we get. What's the distance that we get? 50 yards, Russ. Nah, maybe not. We'll find out. So we are going to be traveling at 14 meters per second and hit a ramp at 60 degrees. The top of the ramp is 7 meters above the level floor there. All right? So that's what we is going to figure out. All right, pause the video, see if you can do it. Okay, first thing we gotta do is break apart that speed here. So 14 is there, which means this is 7, and this is 12.12. Alright, once we have that, we have to figure out time. So we're gonna use the second equation again. So this is d is equal to d0 plus v0 t plus 1/2 at squared. So d is going to equal 0. d0, we have a starting height this time, which is going to be fun, let me tell you. But I'll tell you in a second. v0 times t plus 1/2 times negative 9.8, right? Because it's going down and we're pointed up. T squared. Now, how do you solve for this? Well, can you feel it? Are you feeling it? You're going to need an old friend here. Your quadratic formula. Oh, yes. So negative b plus or minus the square root of b squared minus 4 times a, which is 4.9, right? Are we okay with that? Negative 4.9. 4ac all over 2 times negative 4.9. 4.9. Oh, okay, so there's that. Now, do you have to write all this out? If you want to use the... No. If you have something on your calculator and you can solve it, great, you can do that. If you don't, well, I'd give you a program for it, but I can't. Or you can solve it by graphing or whatever. I don't care. I'm not going to test you on quadratic formula. Long story short. Anyways, you get two answers. T is equal to negative 0.48 and, well, I guess or technically, 2.96. These are your times. Now, one of these times doesn't make sense. It's not this one, because time has to be positive. Alright? So, what we're going to do now is take this guy and use d is equal to v times t. We know what our velocity is. Our velocity is 7, because that's our x velocity isn't going to change, times 2.96. So multiply them together, we get 20.7 meters. That's how far we're going. Now, I kind of lied. This does have some meaning to it. If you took this parabola and extended it back, this is the time it would take to go like backwards in the parabola, but we're not interested in that like ever. So, you know, it is what it is. Okay, so there's your projectile motions in a nutshell. Yes, it is tricky. Yes, it is fun. Yes, it is important, and it will. This stuff sticks with you. So, we'll help you out with questions you have. Good luck.